Welcome back to part 2 of your lesson for 12.1, where we're talking about limits and we're graphing them to determine is there a value for which this limit exists? Does it also, right now we're going to talk about, is the limit unbounded, or does it approach infinity or negative infinity, or does it exist at all? So I'd like you to look at this example. We are going to graph this equation, and you should recognize a couple things. One, I know the numerator factors to x minus 2 and x plus 2, but that gives us absolutely no benefit because the denominator can't cancel as it did in our previous example. So I don't need to worry about doing that right now. I do notice that there's a higher exponent in the numerator than the denominator, which it signifies that you're going to have an oblique or slant asymptote. You remember when we did these? And you can do long division and you can figure out what that is if you really want to be specific. I did kind of sketch mine out. But when you put it in the calculator, don't forget your parentheses, and you graph it, it will come out looking similar to this. Now, I can't see the other turn, the other branch, so to speak, because of the window of my calculator. So I'm going to, if I want to, I could just zoom out just to get a quick idea of what it's doing so that I can see it. I could have changed the window as well. There it is, and that's also very easy to see the slant or the oblique asymptote. Now, we are taking the limit as x approaches 3. That's at that vertical asymptote. So we want to know what the graph is doing as it approaches 3 from both sides. So if we want to just look at the graph and we say, as the limit, as x is approaching 3 from the negative side, so as it's coming in this direction, what is it approaching? And you may think, oh, well, it's getting really, really, really close to 3. Not exactly. All right, you are looking at the function, not the vertical asymptote, not what x is. So that's a common mistake. So as x is approaching negative 3, and think of the function, think of the graph as it's coming in and it's approaching negative 3, the graph is going down here, and it is approaching negative infinity. Very, very, very small number. Okay? Well, I'm going to write negative infinity. We'll look at this on the table as well. And if I look at this branch, if x is coming in and approaching the 3 from the positive side, so it's coming in here, as it's approaching the 3, think of what the function is doing. The function is going to go way, 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 way up, and it's going to approach positive infinity. I'll move this so I can write that in. Okay, these are not equal. Those are not equal. So the limit for this particular function at 3 does not exist. Now I do want to take a moment to look at the table. If we just look at the table, you'll just see error, and you won't be able to tell what it's really doing as it gets really, really close to 3. So we're going to change the table. We're going to let it start at 3, but we're going to let it change 0.01, you can do 0.001, doesn't matter. Go back to the table, and you'll be able to see that as it got closer and gets closer and closer to 3, and you can change this, remember, you can make it go even by smaller increments, it's getting really, really small. It jumped from negative 244 to negative 494. And here, look how it's jumping, how much it's increasing. When as it gets really close to 3 from the positive side, look at that. It was at 131, now it's at 506. It's going really, really high. And the smaller, the closer you get here to 3, the tinier increments, you will see that that number is increasingly large and increasingly small. So that limit does not exist at 3. Okay, we're going to try this one. Let me get my other calculator set up. Next example we're going to do is examining the limit as x approaches 0 of negative 2 divided by x to the 4th. So I've gone ahead and I've put that in the calculator. When you graph that, It's this fun little shape, and that just looks like it's not doing much of anything, is it? And we can't really see what's happening on the ends here. So I'm going to go ahead and zoom in. See what's happening. So it's getting really, really close there to 0. All right, as a matter of fact, there's an asymptote there. And if you notice, it's going straight down. So if I go back to the standard version, it's going to keep on going down, 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 down this way. So as you approach, slide this over a little bit. As you're approaching the limit of, as x is approaching 0 from the negative side, so it's coming in this direction from the negative side, it's getting really, really close to 0. Can you tell that the function value, the graph itself, is going to go down, 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 and be really, really, really small, and it's going to negative infinity. Now the limit as x is coming in this way, and it's coming in and getting closer to 0 from the positive side, as well, it is going down, 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 down to a negative infinity. So both of those, since they are equal, the limit is in fact negative infinity. Now you may say, well, infinity is not a number, so how can we approach that specific number? They are both approaching the negative infinity. They are approaching the same value, very, very small negative number. And so you can say that the limit is negative infinity. And I have checked with the calculus teachers, and they also agree that that is acceptable, and that's what they want us to do. All right, let's look at a little trig here. You haven't done any of that in a while, so let's go ahead and get this graphed and get this queued up. Before we start on the cosine, I do want to come in here. I didn't write in the answers here in these boxes, so I want to make sure you have that. That one doesn't exist, and this is negative infinity. Similarly, if this graph was up here and they were both going up, symmetrical there to the y-axis, the positive y-axis, then it would have gone to positive infinity. I just happened to pick one that was going down. All right, let's look at the cosine function. Cosine function's kind of fun. When it graphs, looks a little weird. All right, I can't really tell what's going on in there. So what I'm going to do is I'm going to zoom in, and I want to see what that does. Let's see what happens. Now, we call this oscillating. We call this bouncing back and forth. Basically, as you are approaching 0, it bounces back and forth. It's not approaching one specific value. It's oscillating, the graph is. And similar to a wave, right, it's going back and forth, back and forth. It's going up and down, it's going up and down, and it can't decide as the values get closer to 0. So when you graph that, you need to determine that the table, and the table I'll show you does the same thing, but the table shows the values. Now I'd like you to have this word in your notes, oscillating. Values that oscillate or bounce back. So as x is approaching 0 from the negative side, okay, as it's approaching 0 here from the negative side of the function, and as it's approaching 0 from the positive side, as it's coming in this way from the positive side of the function and trying to get to 0, the limit does not exist because you cannot approach one specific value for both the positive and the negative, both one-sided limits. Let's look at the table for a minute. If you just go to the table, remember you've got to change it because it's not going to show you anything. If you go to the table and make it start at 0, but let's change it to 0.001. Let's see what that does. Do you see how it's bouncing back and forth between positive, negative, positive, negative, positive, negative? And they're symmetrical, Right? So they're going to be the same value, but it cannot make up its mind. It keeps bouncing back and forth, positive, negative, and therefore it is oscillating, and it's not going to give you one particular value as you approach 0. All right, now we're going to do a couple of them on the bottom. So I am going to pause the video, and I'm going to graph all of, oh, this one does not exist either. And I'm going to graph the 3 on the bottom. I would encourage you to try to do the same. I'd like you to graph these and see what you can get for the answer, and then when we come back, we'll see if we have the same thing. All right, let's see what you got for example 8. Here, when you graph this, you notice you've got to keep the 1 and the x to the 4th separate, minus 3, so that it will provide that, do that operation together. All right, now when I graph that, I get this creature, and I want to take the limit as x approaches infinity. So you need to think about as x is approaching infinity from the negative side, and as x is approaching infinity from the positive side, and you want to see if you're going to get the same thing. So as it's approaching infinity from the negative to the negative, all right, negative infinity from the negative side, nope, let's go this way. As it's approaching negative infinity, which would be that way, all right, what is it approaching? It is approaching 3. As the function is approaching, as x is approaching positive infinity, it's 3. As x is approaching the infinity from the negative side, it's going to also be 3. So they're both approaching the same value, and I keep saying 3, but I meant negative 3. So your limit should have been negative 3. Okay, let's try number 9. Number 9 is the limit of e to the x as x approaches negative infinity. All right, let's graph that one. So as the x is approaching negative infinity, as x is approaching negative infinity, really, really, really small over here, what is the value of the function? Okay, so as it's approaching negative infinity, it is getting really, 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 really close to 0. It is approaching 0. And you can determine that also by looking at the table. All right, last one. See if you get this one right. And I think you will. Do you remember what our sine graph looks like? All right, so if you just graph sine x, a little wave there, okay? And I want to know as x is approaching infinity, so as x is getting really, really large, okay, from the positive side, is it approaching one number? As x is approaching infinity from the negative side, okay, is it approaching the same number? No, it is oscillating, so it does not exist. Okay, now I'd like to take just a very quick moment, because the video is about over. Look at the big picture here. Big picture is talking about limits that do exist at specific points, maybe where you think the function doesn't exist, but the limit does. And there are specific times when the limits do not exist, and they are approaching infinity or negative infinity. And sometimes you have to look at both sides of the limits. Okay? When you come to class, we'll do an exercise together. Thank you very much.